Quickly, let's go. As for each of these terms, you have to write them in the correct form. All right, so just a coefficient, variable, and the exponent. So 1 over p, 1 over p squared, and 1 over p cubed. You have to change those into the correct form. And then from there, remember I just showed you the notation yesterday. The derivative, or not the derivative, the variable is p. So you can just say d over dt. Or like someone else was saying, you can name this f of p or something of p and then do the dash. That's also fine. All right, so you take the exponent to the front and you minus 1 from the exponent. Same thing there, negative times a negative, now it is positive. That's where that plus comes from, and that 2, and then 2 to the negative 3. Then you do the same thing there, and then you just need to write all of them with positive exponents. Okay, any questions on that first one? All right, for C, you just have to multiply those brackets out so that you have your separate terms, and then you can find the derivative, which is quite simple in this case. So when you multiply them out, you just do FOIL, right? You simplify your like terms in the middle, negative 4b plus 2b, that's negative 2b, and then you can take the derivative of each. Now for D, you have to split the fraction up. I didn't show that as a separate step, but you could have if you wanted to. So if you wanted to say c cubed over c minus c squared over c plus 1 over c, that's fine. It's like an in-between. And then you simplify each term from there. This is similar to the example that we did yesterday. You can't take out c as a common factor at the top because c is not a factor of 1. Okay, so for this one, you have to split it up. So you get c squared from the first term, minus c from the second term, and this one you just need to write as c to the negative 1. And then you can find the derivative of each term separately. So 2c minus 1, and then minus c to the negative 2, which we must then just write with the positive exponent. Any questions on top? Fine, all right. Let's go up again. Sorry, I did E there at the top. So E was just basically a lot of multiplying out. It was a bracket cube. Guys, that's not the same as just the first term cubed and the last term cubed. Please, if you do that, that's a breakdown. You get 0 straight away. So you actually would have to, you could do like an in-between step where you could say, okay, 4p minus 3 cubed is 3 of those brackets multiplied together. Yeah. Really? Oh. Okay, sweet. Oh, let me just see here.
I don't think the first bracket was that. The first one that you
Sorry, why? I made so much work for myself. Okay, well, guys, let's just look at it while we're here. Because they do often ask you. I'll fix it down. Thank you. Thank you. All right, so it was squared. Sorry, I copied it down wrong. But guys, if it was cube, because I think in the work that I'm going to give you today, there is one where it's a bracket cube. So you would have to turn that into a bracket squared times that same bracket in order to multiply it out. So like I did here. So 4p minus 3 cubed, I know it's wrong, but just if it is a bracket cube, you have one bracket and then the other two you can put together. Right, so then I would square those two brackets essentially out and then multiply out like that. But okay, let me just fix that quickly. Let me just do this, okay. So it was 4p minus 3 squared. Okay, so that is 64p squared minus, 16. Oh my word, 16. Thank you. Just texting you guys. Well done for passing. 16p squared minus 24p plus 9. Right? Okay, there we go. So now you just need to find the derivative of that. So then, therefore, d over dp is 32p minus 24. There we go. Sorry about that. That's easier, yeah. Okay, thank you. Next one. Guys, this one was a trinomial that you have to factorize in order to cancel out the x plus 1. So now in this case, you don't just have one term in the denominator, so you can't split your fraction up. Okay, you can only do that if you have one term. So if we have like just an x at the bottom, for example, then you could split your fraction up. If you have multiple terms, this is going back to like grade 9, grade 10, where you have to simplify algebraic fractions. You have three terms at the top, 2 at the bottom. So you can't just cancel out, you have to factorize wherever you can. Okay, so the top one is a trinomial, so you would have to factorize that. Now guys, I'm going to teach you a little trick. Obviously now from you. If you see something like this, you kind of know already that you have to cancel out the x plus 1, right? Because we just need separate terms. So what you can do is you can automatically make your first bracket x plus 1, and then use your first bracket to get the second bracket, like we practiced when we did factor theorem. So I'm just saying here, if I'm getting something like this, I know that in order to find the derivative, I have to cancel out the x plus 1. So that means that one of my two brackets at the top is going to have to be an x plus 1. All right? So you would do that. Now to get your second bracket, you can just say, this is now instead of factorizing this trinomial, because there's a 2. Okay, we don't really like factorizing those. You can just say, okay, what does I multiply x by to get 2x squared? 2x. What does I multiply 1 by to get that last term? 1. 1 again. Right? And then you can just check that it does actually work. That I do get my middle term. 1 times 2x is 2x, and x times 1 is x. So I do get my plus 3 x. Okay, so that's almost like a little cheat. You know that one of your brackets has to be an x plus 1. So put that x plus 1 there. Then figure out what must your second bracket be to get the original triangle. Or you can just factorize normally if you want to. That's fine. Tell me what is your question? Alright, so once you have your 2x plus 1, right, you cancel out now, you get your 2x plus 1. The derivative of 2x is just 2, and the derivative of a constant is always 0. Okay, the gradient of this straight line graph is just 2. Okay, remember that's what the derivative is. Okay, now for the next one, I took out 2 as a common factor there at the top. I suppose you could have just split the fraction up right in the top. That probably would have made it a little bit easier faster if you just did your 2p squared over 2p minus 4 over 2p. That's also perfectly fine. You can do that because there's one term in the denominator. Right, you would end up with the same thing. So 2p squared divided by 2p is just p. And here you would cancel out the 4 and the 2. You would be left with 2 over p, which is what I got there. But you then just need to write that as 2p to the negative 1. Okay, I took out 2 as a common factor, and then I have to split up the fraction anyway. All right, so it would have been quicker to just split it up from the start. And then you need to find the derivative there. The derivative of p is just 1. For this one, you have a negative 2 there. So when you bring down negative 1 to the front, you're going to say negative 2 times negative 1, which is plus 2. And then p to the negative 2 from there. And then you must just move the p to the bottom of the fraction. Any questions, guys? What was that now? 6. All right, you have to do number 4 as well. Now they are getting a bit more complicated as we move on, and we'll see what the ones that you're going to do today. They are also more complicated. So for 4a, there you go. And you guys can make out those fractions. So it was t to the 3 over 2, which is actually 1.5, right? That's 1.5, and then plus 2t to the half. So guys, both of your terms are written in the correct form, right? Where it's a coefficient, a variable, and an exponent, so you can find the derivative straight away. So you're going to take the 3 over 2 to the front, t, and now 1.5 minus 1 is a half, guys. Right, so that new exponent is a half. Plus, you have 2 times a half now, which is 1. And then t, a half minus 1 is negative a half. And then what you just need to do is you need to move this t, whatever has a negative is further, you need to move to the bottom and make it positive. Yeah.
The first three are going to. We need to, see one in the top.
Yeah, that's not, yeah. There's 3 t to the half over 2. Yeah. Any other questions on A? All right, B, there we go. B was a bit more complicated. Now, guys, this denominator that you have is t to the half. Right, so you have 2 terms over 1 term. So what you have to do there is you need to again split your fraction up. So you take t over t to the half plus 1 over t to the half. Now for this one, we need to remember our exponent laws, right? Do we see that we have the same basis? Right, we have a base of t divided by something with a base of t. What do we do with those exponents then? Top 1 minus the bottom one, all right? The top exponent of t is 1. So when you're doing this, we're actually going to do t to the 1 minus a half, which is t to the half. All right, so we haven't worked with exponent laws in a long time. It just pops up every now and then. But here you have to do your division of exponents law. Let's apply that. For this one, you just have to make that exponent negative, right? So let's go with the 4. Then from there, you have to find the derivative. So you have to take the exponent to the front, a half t, and then you need to do a half minus 1, which is negative a half. For this one, you're going to take this exponent to the front, so negative a half t. And now negative a half minus 1, guys, is negative 3 over 2. Okay, so that becomes the new exponent. And then for both of these terms, because you already have a 2 in the denominator, when you move that t down, it needs to be written next to the 2. Okay, let's make sure that you're doing that. So guys, this will be a 4, possibly a 5-mark question. So you will get 1 mark for simplifying that, 1 mark for simplifying that, for getting it in the right place. Then a mark for each of these derivatives, and then the final mark for getting those exponents to be positive. So that's, 10% of a test, right? That's right.
Yeah, how many of these questions are going to one?
They usually do a couple and they will test different things. So there might be one with like brackets to the top, and then there might be one here which is like a fraction and a surd at the same time. It also depends, like in your test that's coming up, and there's somewhere in May, there's a lot of content in that test. So they probably won't ask more than one. Because that's all pretty good. Yeah. Yeah, not straight draw. Okay. All right, there is C, guys. Yeah, we revised straight draws and you practice straight draws across, but it wasn't actually, we weren't supposed to do that. Oh, we did. I taught you everything else. Any questions on this one? Fine. Okay, then the last one was a cubic expression that you have to factorize. So this is what we practiced when we did remainder and factor theorem, right? So remember, how do you do that? You do that whole trial and error thing. So whenever it's a cubic, you need to do that. You sub in x values or your t values in this case, until you get one that will make the whole thing equal to 0. But now, guys, again, you can use that cheat because again, one of my brackets is going to have to be t plus 1. right? So that I can cancel out the denominator. So that's what I did. I didn't even check. I just said, okay, my first bracket is going to be t plus 1. And then I used that to get my second bracket. So, and this is what we did when we did remainder and factor theorem, when we did actually doing like factorizing cubics. So t multiplied by what? What does you multiply t by to get t cubed? T squared. What does you multiply 1 by to get 2? 2. Then to get your middle term, we need to have a negative 2t squared. At the moment, right, if we have that, we have plus 1t squared. So if we have 1t squared, we need to get to negative 2t squared, we need a negative 3t squared. So that's why that middle term there is negative 3t. And now, guys, are you going to try and factorize that? Is that going to help you if you want to find the derivative? If you factorize, you're going to end up with 2 brackets again. And can you use the derivative rule if you have 2 brackets? No, you need separate terms like this. All right, so we actually got rid of the problem here. The reason why we can't differentiate, find the derivative of this straight away is because of that denominator. All right, so when we cancel out that t plus 1, we're fine. We now have 3 separate terms and we can find the derivative of each of them. Okay, is that all you have to do? Yeah. All right, guys, was this all in question 4? Hey, just the 4 A to B. Okay, now I want you to do number 5 and 6. I'm not sure now how many questions there are. Just check quickly.
No.
All right, guys, I would like you to do number 5. Number 5 is percentage class. And 6 AH. Number 5 and 6 AH. Guys, it's a lot of work. You have to half an hour. No. 45 minutes actually. You have just under 45. So now you got here 42. Yeah, that's number 5 and 8. 5 and 6 AH.
Shut up.
All right, keep going, please, guys. It is a lot and they get quite complicated, so you're gonna have to think back to your exponent rules, algebra, word fraction, all of that stuff. Okay, keep going, please.